as Shannon mentioned, we'll take questions along the way written into the question box. At any time you have a question, just put it into the question box. But we'll be answering all questions at the end of the seminar so that we can keep the flow going here. We'll keep going through at the end of the seminar until all of the questions are answered. So feel free to stick around. If you need to leave right at the hour, feel free to do that as well. Let's see, any other housekeeping issues? I think we've covered that. So somebody asked a question already. Will there be a webcam? No, I won't be using a webcam. We'll try and keep the bandwidth. There's a lot of animations in the slides, so we'll try and keep the bandwidth focused on that. If you are at this point having any technical problems for any reason you can't hear or see, put that into a chat message to the organizers and we'll see if we can help you out. Okay, so let's start off with just a little bit of an overview. This seminar, or a version of it, was given at the AHR Expo show at the ASHRAE convention earlier this year. It's now been modified and expanded to share some more information. This is really about some concepts that are brewing in the industry, some things that we're working on. It talks about the focus for enterprise solutions when it comes to building automation systems and building management systems. For those new to LonMark and to who we are, let me give you just a little bit of a background here on who I am. Hopefully the next slide. I used to work for LonMark as the executive director. I used to work for Echelon Corporation for many years, and now I have my own consulting business called RBCG, Ron Bernstein Consulting Group, and I'm also a director of the Smart Buildings Institute, and we're focusing on education and transforming the industry through innovative practices. So that's a little bit about me. That's enough about me. Let's move on. So we'll be talking about these concepts of building automation, open systems, and how they're leading to greater enterprise integration. And some of the initial key concepts are, we're going to talk about some definitions and some basic concepts. We'll talk about the progression of smart buildings. And if you don't necessarily understand what all of these terms mean, we'll go through all of these terms from DDC to BAS, BMS, EMS, EMS. We'll talk about those. We'll talk about integration and interoperability. And we'll introduce a concept called the multi-tier model for enterprises, the multi-tier architecture model, which leads to a sort of a division of responsibility between the different tiers or the different contractors that are involved typically in a building project. So we'll talk a little bit to introduce that concept. Won't go into a lot of detail on that. That's a whole nother webinar. But that will lead to the final topic, which is about enterprise applications and dashboards and user interfaces. Okay, sorry, we're having some technical issues there. Okay, there we go. So let's start with some definitions. So very often when we start talking in this industry, we start talking about things, then people have different connotations as to what some of the terminology means. There are a lot of acronyms that are thrown around. Every industry has their TLAs and FLAs, three-letter acronyms and four-letter acronyms. So I'm going to define a few of them here, just give you a rough idea that what I use in the course of this presentation. I will point you to an article that I wrote recently, was published last week in a magazine called Consulting Specifying Engineer. So if you write that down, Consulting Specifying Engineer magazine, the sidebar is a list of all of these definitions, and it's probably a good, maybe a useful tool to have. So Consulting Specifying Engineer, just do a search on probably my name and you'll come up with two articles, one roughly around this topic and the other about definitions. So the first one, we've kind of progressed from the world of DDC, Direct Digital Control. And direct digital control is the concept of controlling the environment, mainly stemming from, in the buildings market, from the HVAC world, or the heating and air conditioning world, to where we can control equipment instead of through a pneumatic type system where we are using air pressure to control things. We're controlling things through a digital or electronic model. That's given way now to the building automation system, BAS, which in my definition is the control level equipment that performs its functions according to a set of rules and algorithms. And then on top of that would reside a building management system that manages or oversees the building automation system. One key differential between the two is that the management system is not necessary or mandatory in order for the automation system to continue to perform its functionality. In other words, it's not a single point of failure. If your central management system goes down, you will not lose access to your control system. Your control system should continue to operate. And then there's a higher level concept called the energy management system. And with the progress of control environments now moving to energy environments and energy efficiency programs and energy sustainability, the building management system now is feeding information into an energy management system. And we go up the food chain even a little bit more. We hear the terms EEMS and EIMS, which stand for Enterprise Energy Management Systems and Energy Information Management Systems. And these tend to be the higher level, or in some cases the highest level, where we're accessing many buildings and many subsystems, all from a central enterprise. And some of the key issues become that we can't get access to everything that we want to see, all from these central enterprise systems, without going through a tremendous engineering challenge. And then on top of the data that's being collected at these central enterprise systems, we have a graphical user interface. And along the way, all of these different elements have graphical user interfaces, but there's becoming an issue with how do we get access to information from all these different elements, these disparate systems, in a consistent and user-focused view. We often refer to that as the HMI, the human-machine interface, where we can see information, we can visualize it, we have various dashboards and screens that are user or appropriate for the specific person. So we have a variety of HMIs, and then we also have something called M2M, or machine-to-machine, in this case an interface, where now the enterprise systems may need to interact with other non-building enterprise systems in the same environment, where the controlled data or the data sequences coming from the equipment are interacting with other computers and other systems without necessarily having a graphical user interface or a human-machine interface. And one of the key ones we'll talk about, some of you may be familiar with something called automated demand response, where a utility sends a message, hey, go do a load shed on your building, and let my computer know that you've done that so we can calibrate and know how that's being affected. And that would be a machine-to-machine interface. So as we go through this process, we have all these different levels of the system, and you'll get the handle on it here. So definitions part 2, we start off in the data world as the first level is monitoring the system. Let's see what's up. What's happening in the system? It's basically just a view into the system. In the old world, this might have been an old green screen monitor and a concept called WYSIWYG, what you see is what you get, and we'll talk a bit about that. The second level would be command. So instead of in monitoring mode, we're only seeing what's going on. In the second level, we're giving some command, a direct interaction, do this. And this is things like overrides, very simple command. Turn it on, turn it off. And the next level up would be control. Now control, a slight variation of the definition, based upon multiple sets of information. If this is true and this is true, then do this. Well, it's a little bit more abstract, where we're accessing information from a control environment in multiple sets of data that then issue a command through a sequence. Next level up from there is the visualization, and this is the visualization of data that's aggregated, so multiple sources, such as multiple thermostats or multiple occupancy sensors that we can bring up to a screen and see that data. The next step up is analyze. So once we've got this data and we're visualizing it, maybe we want to run a computer algorithm on it and turn that data into information. Data is useful if you know what you're looking for, but information's better. Information would be something along the lines of we've got all of these VAV boxes in a building, and we want to know which ones of them are performing correctly. So we might take that data in, run an algorithm on that to determine what's happening with them, and then point out which ones are not running efficiently. The next level up would be reporting. So turning information into a validation or justification. So reporting would take the analyzed data and then combine that into something that would be, again, a little higher level of a validation process to say, hey, how are we doing based upon what we did last year or last month or even yesterday? And the next concept is interoperate. And you've heard maybe in the marketplace, interoperable, or much of what LonMark International does is focused on interoperability concepts. And how is this stuff all working together? And how do we make it work well together? By sharing information in a common mechanism or a common way, such that all the equipment and systems have a way of sharing information without having to re-engineer each time. And that leads to this concept of integration, where my information plus your information equals something really good. That's kind of my short version of that, where if I can take multiple pieces of the puzzle, bring them together, and I can create something that's bigger than 1 plus 1 equals 2. 1 plus 1 equals a whole lot more than 2 when you can get and do something with information from different systems. So this is a very, very short version of some definitions that we'll be using throughout the course of this presentation. So some basic concepts. We'll talk about some of these concepts, smart buildings, such as integration of multiple building systems, like lighting and HVAC and so on. Integrate or a common platform for data mining and extraction. How do we get that data from all of these different systems into one open communication interface and one common infrastructure and data delivery mechanism for accessing that data? And then up at the enterprise level, how do we get access to enterprise level data? And following more of an IT model than a buildings model, and the convergence, we'll talk a little bit about the convergence between IT standards and communication interfaces with the building level. And then a little bit about be able to act and react to information. So as information comes in, coming from various sources of data, and we can analyze that, what can we do with local internal influences and external influences going up the food chain? And then we'll talk a little bit about some basic capability, the monitoring, alarming, scheduling, being able to get access to a central or remote access and a variety of user options and interfaces. And we'll talk about some of these key concepts and benefits here. So let's start with a little background. So when we start talking about graphical user interfaces, the old model of the one-size-fits-all model might follow something that some of you may be familiar with called WYSIWYG. WYSIWYG is an acronym for what you see is what you get. And this is the old-style model that generated from the early days of graphical interface or user interface. They were really text interfaces that were from the old green screen monitors. You may have seen these types of monitors in a local computer museum, or for those of us who are a little older, our first computers may have been old green screen monitors. And the concept of what you see on the screen is what you get. There is really nothing behind it. It was a data to visualization model that followed this. And we're progressing through that, and I'll digress for a quick second, and some of you may be familiar with this image. For those of you who are movie fans and remember the movie called The Matrix, that was sort of an extension of the green screen monitor to a visualization tool that was used to visualize the entire matrix. And here's my little matrix view coming down the screen. You may not be able to see the animation here, but the columns of data were flowing down on the screen, and this guy Tank, if you remember him, he was the guy who could look at that screen and tell you everything about the matrix. He was programmed by the tool to be able to accommodate the user interface and found that useful, whereas most people wouldn't find that useful. We wouldn't necessarily be able to see the screen and know anything about what's going on that, but the necessity provided that. Well, today we often see screens and dashboards that are data-focused rather than user-focused. Data-focused meaning that we get lots of information, thousands of pieces of data, but they're not necessarily useful to the end user. So this is a picture of a desktop showing many different user interfaces. And if you take a quick minute here and just kind of count the different user interfaces on this, you might think that there may be 5, 6, 7 user interfaces on here. Well, user interfaces come in all sorts of different flavors, not just monitors, screen monitors. In fact, in this image of this desktop, there are over 20 different user interfaces between the monitors, the cell phones, the telephones, the iPad, and so forth. There are over 20 different user interfaces, and we're interacting with all of these different systems in a variety of different ways. Well, if we start thinking about how we interact with systems, we might want to rethink the strategy of how we access these systems. Here's another example from a college campus at the University of North Carolina in Chapel Hill. In this particular environment, they have 12 different user interfaces with lots and lots of different graphics and screens on that. And in this case, they have seating for 3 different operators to be able to see the different screens and see what's going on around the campus. And this is more a bit of a cleaner model than something like what the U.S. military is working on. And this is a project called the Utility Monitoring and Control System, or UMCS, that is being sponsored and focused on by the U.S. Army Corps of Engineers, where they want to have one user interface, one operator workstation, where they can access all of the various systems and the operation and maintenance systems on a particular military base or a base-wide system, where all of the systems are networked together, and network systems can transfer the data between the DDC, the Direct Digital Control System, and the front-end computers, the UMCS computers. And this is to try and solve a problem that they've had over many years, where vendors are bringing in their control environment and bringing in their own user interface. In this case, at Fort Bragg, you can see the image on the table here. There's actually 12 different notebook computers running different systems, and every computer has its own interface, its own configuration or setup or tool, and its own user interface. It's a graphical user interface, and that just wasn't an effective mechanism for accessing all of those different systems. So they tried to come up with a solution that was less proprietary and more interoperable. And the concept is, what's the solution? Well, one integrated multi-vendor system with no future dependencies on any one contractor or controls vendor. In other words, an open system. And in their definition of an open system is one system, multiple buildings with controls installed by multiple vendors are integrated into one common environment, one common system. One common front end that provides users with the capability to interface with all buildings, all of the various buildings on the site, monitoring, supervisory control, data access, and so forth. one common tool for network management. No more need for all of those different visualization tools and user interface tools for managing the system, and one common tool for device configuration, for configuring all the DDC devices. And this is probably the big one, is the independence from the owner to the contractor. So no future need for the original installing contractor. Additions, modifications, retrofits, changes can easily, without significant additional cost, be made to the system without dependence on the original contractor, nor require substantial engineering or other technical development. And that's a very key concept here. This is moving the ownership of the system to the end user, to the owner, rather than the owner or host of the system being tied or locked to a specific vendor or set of vendors. So this is kind of creating the model for a more open system, more open environment, which really means that you need access to information. And the information coming from multiple sources, the list over on the right-hand side, alarming, control, monitoring, set point changes, overrides, and so forth. And being able to get at a variety of different visualization tools, of the different mechanisms for seeing the data, depending upon who you are. If you're a controls engineer or an operations engineer or a supervisor, you might have different visualization requirements for all of your different systems. And so this allows for a model where all of these different types of tools can be used on the same system accessing the same data. So in this image, there's everything from an Excel spreadsheet, believe it or not, that's what this is in the upper left corner, to something like a nice graphics program that's a standalone program running off a server, to something similar here that's a web-based interface that's using a web browser model, to something that looks more like a user interface rather than a controls or a technician interface. And all of these different systems are accessing data in a common way. And sort of the wish list here is, how do I get access to the data from my browser, from any computer on my network or from home, with different access levels for different personnel needs, with my full campus integrated into one system, and all of my systems working together to simplify my facility management and reduce my operating costs. That's sort of the wish list of what people want and have been asking for. Which means that we need to identify the different levels of data and who the various stakeholders are, who the interested parties are, and then start creating visualization tools and access tools and mechanisms specifically for those levels. And as we kind of move up the food chain here, the level of information coming from a device to an enterprise may start very common and similar way, with the temperature, pressure, status information being extracted and then extended as we move up from the device to a room to a zone and all the way up to the enterprise. But the source of the data remains consistent all the way through. So when we're doing an energy savings plan or doing a demand response program, we might still want to monitor the temperature and seeing if we're effective when we're doing our setbacks for temperature, and we want to have the same data say, hey, we're comfortable, we can operate, we're not in harming our worker productivity or our environment, but we're still able to respond to events. So I've coined a new term instead of WYSIWYG. When we focus on user interfaces, I like the term WYSIWINS. And everybody has to have a new term. One must be upwardly buzzword compatible these days. So this new term called WYSIWINS stands for what you see is what you need to see. So this is a different concept. If we take the visualization model to the point where the operator sees only what he needs to see to do his job at that moment, then we have a different model of how to create these user interfaces. So what you need to see, nothing more, nothing less, on any platform. So now if I'm a user and I come at it from a user-centric point of view, I might want to see my data on a cell phone or a smartphone or a tablet computer, or I might want to see it on my Android phone, which I personally happen to use, or you might want to see it on some sort of Android platform, or maybe even I want to see it on a wristwatch. I've seen now wristwatches that have full user interfaces on them. And then, it kind of goes all the way up the chain to, I've seen now you put your smartphone in your pocket and your wristwatch has a Bluetooth interface to your smartphone, which gives you the primary interface information, such as the time and the temperature and the weather, and do you have email, and have you missed any phone calls and any chat messages. These things were displayed even last year. I heard about some at CES, at the Consumer Electronics Show. So user interfaces are now focused on the user rather than on the data. And this is a big part of the concept of what we're talking about here. There are some issues when we do this. So in the past, we have really focused on the scope of the building to the campus to the enterprise in a very much a bottom-up focus, very often starting at the HVAC world. The HVAC, heating, ventilating, air conditioning world has really been a driver in the industry for integration, and there's a very common, a very good reason for that, because of the various different user interfaces that have come up and all the equipment that's happening there. The HVAC systems have needed this greater level of integration, and then we start integrating in things like some lighting and occupancy sensors, and we focus on the indoor facilities. But as we go up the food chain, we are really seeing a need for a top-down view, where we focus on the enterprise and the enterprise applications and these graphical user interfaces, where we can start seeing other things other than just HVAC and lighting. We can start seeing things like utilities and demand response programs and outdoor facilities such as parking, irrigation, lighting, outdoor lighting, street lighting, and then the energy side of it, which is the metering and sub-metering side. So if we start looking at a more holistic view of an enterprise, there becomes a need to see a larger or bigger picture. And some of the user interface systems and system integration components follow this kind of subset of integration levels. And here's a kind of a list of some of the more common ones, and it's certainly not an exhaustive one, but the fire, security, access, energy, lighting, appliances, home electronics, the monitoring aspect, the HVAC systems, on the bottom is the energy meter, electricity meter, gas meter, water meter, and we want to get at all of that data from a central server that then collects that data, maybe does some analysis, maybe has some cloud-based computing capability where we can then monitor remotely and offer up some analytics engines, some reporting engines, maybe be able to acknowledge an alarm from our smartphone or tablet. And this model then allows for all of these different systems to share data up into a common interface. So at this point, we're talking about bringing all this data up and into a system, and there's an issue that comes up where we're starting to get some requirement for convergence between the control world or the building automation, building management system world into the IP data world. Well, historically, these two worlds don't play nicely together. Concepts in the controls world don't necessarily transfer to the data world and vice versa, especially along the lines of things like security, access, reliability, bandwidth utilization. The terminology, the education and knowledge between those two different worlds is, there tends to be this brick wall in between, and it throws a lot of confusion into the marketplace and a lot of confusion into how we go about accessing these systems. So we need to tear down this wall. We need to bring a model in where we develop some cross knowledge between the two and affect the systems in a common way, we need some sort of complete system or some sort of interoperability standards and definitions and effective change into these two different worlds, which is sort of the holy grail for making all of this work. And I'll digress for a sec. For those familiar with the Holy Grail, that is the image from the movie that you know, the Indiana Jones model. And really what we're looking at is trying to find a way how to bring these two worlds together. And it hasn't been easy. There are no definitive standards. Over in the controls world, we use things like LonMark and BACnet and Zigbee and Modbus and Dolly. And over in the data world, running on top of Ethernet, we have UDP and FTP and TCP/IP and a whole bunch of security acronyms that I won't go through. And these two worlds don't necessarily play nicely together from a management, from an interoperability and an integration concept. So we have to find a model that will make that work. Well, I want to introduce a concept called the four-tier architecture model, where we take the elements of the system and we divide it out into four tiers. The first tier being that high-level enterprise in the enterprise infrastructure, typically running on some IP backbone. Maybe it's a fiber or an Ethernet backbone. And then on top of that, or beneath that, we add in the building infrastructure at tier 2. The building infrastructure is often the control network standard and open standard, like the LonMark standard and LonWorks technology at the building level. And then we have the system and subsystem equipment level at tier 3, which defines the interaction of, let's call it, the HVAC system. And the HVAC subsystem has its network, its devices, and maybe it's running on a router and a sub-network underneath of tier 2, where all that information is being combined together. Also in the tier 2 model, there might be a building level IP backbone that is not connected directly to the enterprise except through a specific server, and I'll show you an image of that in a minute. And then kind of a newer concept is this tier 4 architecture, which is the low-level sensors and actuators, not things that are connected through a control network, but things that are connected to a specific controller. Things like a 4 to 20 milliamp current loop, or a thermocouple, a 0 to 10 volt sensor, or a relay that's directly connected to a controller. And those types of devices have their own requirements for their range resolution, their environmental conditions, and so forth. So as we get this data coming from these different sources, we've got this different level of abstraction that I mentioned earlier. And we also start to see a model where the contracting, or the entity that's going to be responsible for these different tiers and what happens at these different tiers, starts to follow a more contractor-based model. If those familiar in the North American market with the Construction Specification Institute's multi-tier model, the divisions of responsibility, we start seeing combinations of different divisions, where we start seeing these Division 25 specifications, for those who are familiar with that. The Division 25 specification starts to incorporate some of these concepts into a single specification segment that incorporates these four-tier architectures that then relate or interact with other tiers such as electrical and mechanical and plumbing and so forth. So a more complex diagram, this is a kind of a network architecture view, where on the lowest level here we've got a sensor and actuator bus. I think you can see my mouse pointing here. We've got a sensor and actuator bus down here at the device level. This is the tier 4, where maybe we have probes and relays and switches and low-level sensors and actuators connected in through a controller, and those controllers are then connected to an equipment and device level bus, where all of the different types of equipment all share information on this control network that then has one access port through a router into some sort of firewall or switch connected to the site LAN, or the Ethernet site IP backbone. And then on that backbone, we might have a server, and that local BMS, remember the BMS, the Building Management System server, is sitting here accessing a database where we can then have some sort of visualization, a dashboard. And then we might connect that to our enterprise and then have enterprise-level servers for analysis and visualization and user interfaces that connect up to other equipment and other sources of data or destinations of data up through the enterprise. And this is sort of that four-tier model, and we can start segmenting our specifications and areas of responsibility along these lines. So that leads to this concept. Well, I think there's some enhancements here. Oh, yes, sorry, there's going to be a few builds here. We're finally done with the picture. Basically, the concept here is that we can share information down at the device-to-device level. This is the building automation system level where it can operate and do its job. And then if there's a connection to the building management level, we then can get access to the data from a visualization tool model. But if for any reason this router or this firewall were down, the building automation system continues to do its job, and the building management system here becomes a supervisory system. And then we can bring data all the way up from, say, our thermostat, all the way up to the remote access sensor, the tablet computer and smartphone model, and we can still see that data all the way through the process as long as we have connectivity, but it doesn't become a single point of failure. So some simple integration concepts here. We're basically sharing data from sensors like the occupancy sensor of a lighting system also being used by an HVAC system and security system. We've got an energy consumption data that's being able to be used by a demand limiting or real-time adjustment program such as demand response. We've got the concept of scheduling access to the various control systems by office workers, such as using your calendar program to turn off your lights in your HVAC and notify security if you're going to be out of the office for the day. Things like alarm management, where we're monitoring alarms and multiple recipients for the same alarms so that various people are informed of what's happening in the system. Remote acknowledgement and response, predictive maintenance capability. All of these are some simple integration examples of what you can do once you have an architecture where everything starts working together. Well, now we'll introduce this concept where not only are we talking about a smart building, which has its smart information in it, but we now have a wide variety of smart, let's call them other systems or platforms. Smart grids, smart metering, smart lighting, indoor and outdoor lighting, smart access control and security systems, even smart elevators, and we want to bring that information up into a common enterprise application. Well, there's a challenge with that it tends to be that all of these different systems have their own standards or their own proprietary worlds that they live in, and they're not necessarily playing nicely with this open concept. So we need some mechanism to bring that data up into these enterprise applications in some sort of building to enterprise interface, some sort of protocol agnostic model to bring data up into these systems. And we'll start talking a little bit about this enterprise application standard interface concept, where we need data coming from things like IP852 and BACnet over IP and the LonMark standards, 14908 standards. Maybe there's a wide variety of building level standards that are bringing data up into a common, let's call it a common database and message formatting structure that we can then bring up and into an IP-based backbone such that the source of the data doesn't need to know or care about the destination, and that there's a common model for sharing that data. And that starts creating this concept from an individual controlled environment, maybe an HVAC system, to a more smart building where data from multiple different subsystems becomes more integrated, or into a grid-aware building where all of the different systems can work together in a multi-platform, multi-protocol, cross-silo framework that allows for new applications and things like the dynamic load modulation and load control, where the grid applications don't necessarily need to know or care that this building is LonWorks and this one's BACnet and this one's Zigbee and this one's something else, that all of those different systems can interact in a common way. So we start seeing this device-level network being able to share data in a common way to the enterprise level. And what's needed here is this platform example for a smart building where there's an open model at every layer from the system to the device, and we can share information. And this really doesn't exist today. This concept of a one-size-fits-all model for data flowing up doesn't exist. There are some models, I'll share with you in a minute, some of the work efforts that are involved to try and do this, but it's still a science project. So the concept here is that we're now moving data from a local hosted environment to a more cloud environment where we have data sources down at the building level, all these little round buttons down at the bottom here, are sources of data coming from a wide variety of electric meters and gas meters and water meters and temperature sensors and occupancy sensors and load shed modules and all that sort of thing, maybe coming up into some sort of data server appliance into a local building management system or a local enterprise management system or energy management system, and at the same time also bringing that data up into a platform where we can share information up into the virtual network or the cloud or the enterprise server in a common way, such that the enterprise applications over on the upper right here can get at that data without needing to know the source or the protocol or the proprietary vendor requirement down at this low level. So we can now bring that data up into some sort of data enterprise model. And we use some sort of standard data format, such as a SOAP and XML model or a web model or a REST model, whatever that model is, that we can bring that data up so that this data set can get access to the enterprise in a common interface. And we can bring that up through to some maintenance applications or ownership applications up there, and we can start building upon some of the issues we've been talking about here, and also have access locally to local applications. What that starts to look like is something like this diagram, where we start focusing on the drivers of the local IT network through a common driver level access that shares data in a common profile model so that the enterprise applications can get at the data without needing to get down to the local level. So there's some work efforts going on to integrate this using LonWorks, BACnet, Dolly, Zigbee, Modbus across an IP platform. There are various models that have been proposed or that folks are working on. And the one that I'm going to refer to today is this EASI platform. And to define some common application interface using the concept of a LonMark International profile, where we define and enable this profile at this green box level to be able to share data up into these applications, where the server here can serve up data that's coming from a central database. We'll see that in the next slide. And so there's a wide variety of tools that could be used to do this, but we need to be focusing on this area, not necessarily we've got a good handle down at the building level, the field level network. These protocols are all well established. They all do their job and are very robust, but they don't play nicely with each other up to the central application. Most vendors today are trying to deliver a proprietary solution at that level. So we're really focused at the middleware level here to develop this standard profile model, maybe starting off with some simple profiles, maybe 10 profiles, an air handler, a VAV box, maybe a lighting system, maybe a rooftop unit, some very simple interaction where we can get that data up and into these user databases and the user-based front ends and dashboards in a common way. Hosting application interface is protocol agnostic, create some commonality and normalization, and unbundle the application from the controls. So there would be, in this concept, a data server appliance which would have a, let's call it a connection. I don't like the word gateway, but a connection or a driver which brings data from a sub-control network and then has a common platform in its upper half of its device where it can share information up into a server and push that data into a server where we can now get access to that information. And then the dashboards and user interface and analytics tools can get access to that data without needing to know, again, what's happening down here. So that's the concept of this Enterprise Application Standard Interface. It is an effort that started over a year ago, or about maybe a little over a year and a half ago, something like that, as a concept which identified this need. There was some discussion at various trade shows. Some folks from the European Norms Group, the CEN group, LonMark, BACnet, ASHRAE, EIS Alliance, and a few end users started this joint working group to develop this concept. And it focused from the end user side and the application developer side rather than from the vendor equipment side, to enable applications developers to work with any subsystem and truly create a protocol agnostic, protocol neutral network interface to these host applications where it's independent of the vendor and a scalable platform, such that support for new interfaces and new driver products can come from multiple suppliers in a common, open, interoperable way, using more IT-based models for accessing the data, whether it's OpenXML or REST, is yet to be determined, and creating some potential for network management tools and managing multiple protocols in one tool environment. So you might want to jot down this website here. This is a current home for the activity that's happening in this world. I host it currently on my website. There's going to been a few folks that have been interested in bringing this into an alliance of alliances, if you will, and creating a cross-alliance platform for developing this. So this is the website that has more information, meeting minutes, some charter, and some examples of what this might look like. So what we're looking for is to develop some sort of tool. I use Thor's hammer here as an example to hit that easy button. How might we do this? And very often these types of things are very successful if there are key end users and owners and users involved in creating the need and the definition of the need, rather than specific vendors coming in trying to shoehorn in their proprietary solution into a more open environment. But there are models that works both ways. So we have to watch what kind of tool. Is it going to be a hammer, or is it going to be some other type of tool? So there are a lot of projects out there that are dancing around this common subject of industry approaches to user interfaces. I mentioned the EASI application or EASI project. There's something called Haystack. Haystack is a project that's sort of an open source model for nomenclature or naming conventions. This is one of the plagues in the industry, that if there is a naming convention issue, it starts off with the integrator installer who might name their subsystem devices one way, someone else defines it another way, and then the host applications have no way of identifying what was the common naming architecture. There's a project that started many years ago now called OBIX, the Open Building Information Exchange, which has morphed into a more machine-to-machine interface and machine-to-host server interface, and it's become rather complex, and it's still going on, but hasn't necessarily solved this dashboarding application model. BACnet Web Services is another model that's been promoted and is in development now to try and solve some of this, again coming at it from the BMS side of things, not necessarily from the EEMS side, but it's still some work effort that's been introduced into this EASI concept as well. There's something called BAMI from the Building Smart Alliance, which has a definition that's starting to work at things like building information modeling. And then there's the most common one, which is the vendor proprietary approaches. And many, many vendors have their own approaches to this, but unfortunately they don't all work together. They're more of a bottom-up approach rather than this top-down approach. So part of what we're looking at here is developing a top-down approach where the user is allowed to pick and choose applications based upon need, not necessarily based upon bells and whistles or proprietary locked-in solutions. A solution that's more open, less bundled, easier to specify, this multi-tier integrated solution model where application providers have a common interface model to build to. This is a big key. We want to create more innovation in the marketplace. Well, the app developers and the smaller companies, as you'll see here in a minute, need to have a common access to the data. They can't be responsible for both the data and the applications. That starts to be too burdensome. And the idea is to lower cost for the applications, increase flexibility for the integrators and installers, enable things like demand response type applications and analytics applications and machine-to-machine applications to expand this model of energy efficiency and get it down to the common everyday commercial building, not just the high-level enterprise campus. So we need better scalability and interaction across the subsystems so that we can use a variety of tools and tool sets on the enterprise level that can interact with these systems. And so there's a group, as I mentioned, working to try and solve this problem, to develop this host application interface independent from the control network, and enable all of the different pieces of the puzzle to work together. So at this point, the development of this is in the investigation stage, the concept stage. I'll share a little bit more about this in a minute here as to where we are. I wanted to share a little bit about the concept of various organizations working together to build this common model. And the vision, sort of the vision here is, think of it as the building's app store. And you've got a variety of applications that you can bring in for doing a variety of things in your environment. So a source for buildings apps, access to building data in a common way. Apps don't need to know or care where the data came from, protocol agnostic, common data representation, and you can go to your building's app store and download your app for 99 cents on your smartphone to do some sort of new innovative solution. And imagine the available on the building's app store model. Think of it from this standpoint. What would I do with data that was available from a common server that I could bring into my application and do something unique with? And how could I create and involve the dashboard and application developers in that model in a more cost-effective way than we're currently doing? So I did a survey. This is for a project I was working on for energy management systems, and was looking at the landscape of where the vendor market is today and kind of where things are going. And this is a chart showing the 6 different elements: software for purchase, hosted services, cloud-based services, integration services, single application does it all model, and multiple application modules, the pick and choose model. And this was research from 41 different vendors, certainly not an exhaustive study, but it is something that had a broad scope. And by far, the model that seems to be evolving is this multiple application modules, the pick and choose, not the one size fits all, and also the cloud-based, moving services up into the cloud. So out of the 41 vendors researched, 20 of them were these multi-module, and 15 of them were offering cloud-based services that were part of their offering. So just a quick view. This is just a quick view of the 41 different vendors or so that were looked at, and there's a wide variety of them. If anyone went to some of the recent trade shows, there are an awful lot of new startup companies and old companies that are trying to get into this landscape, offering a lot of bells and whistles and a lot of functionality and features, but the overreaching problem has been that they are finding a challenge getting this data up into the common front end. So we're talking about a new idea, genesis of a new model, this common profile model, where devices and equipment, subsystems, full systems, buildings, and complete campuses can all be connected together to the enterprise, where we reduce the reliance on single sources of data and proprietary systems, where multiple applications can access common data sources. And we sort of have this kind of, for those familiar with the BHAG model, this big, hairy, audacious goal, and my guy down here with the big hair, user interfaces really should support the user. The system should be a top-down design approach focused on the ability of the user or the interface to the user being able to support that job. And facilities and will continue to be these multi-platform, multi-protocol, and we've got to find a way how these new application standards and interfaces are developed in order to offer greater flexibility and interoperability and greater usability and value. So it's really not the technology at this point. The technology does exist. It's bringing together the right people and the right interested parties that are willing to put a stake in the ground and say, yep, this is what we want, because really in the end, the prize, the end goal is to improve energy efficiency, lower the initial capital cost, lower life cycle costs, which is the equipment, even the infrastructure, using common infrastructures, enabling software and analytics tools and algorithms to be on a common environment, and creating new dashboards and increasing some industry innovation so we get new players coming into the market and offer greater choices for end users and owners. And part of that is unbundling the control from the user interface. And this is a direction the industry has been going for quite some time. And improve integration into these enterprise systems. And that's the prize. That's really what we're looking for. Reducing cost, increasing flexibility and innovation, and offering up better ways of making these systems work. So in conclusion here, we're really looking at the future. The future is this kind of guide for new things coming into the market. So there's some activity I'll leave you with, I think this is my second to last slide here. There's some activity going on with an ASHRAE. ASHRAE is developing a new open controls guide specification which will incorporate this concept of a common profile model and a common four-tier architecture. Myself and I know a couple of folks that are on the call today are on this committee, and we've been working to develop this concept. So there's a guide specification that allows for things like Division 25 specifications and this multi-contractor model and division of the control environment to the enterprise environment and the IT environment in a well-defined integration and interoperable way. So that's one effort that's going on. We've talked about this EASI project. We are currently looking for a pilot project or pilot projects and doing some integration as the next step. We're investigating a couple of folks, and if anybody's interested in piloting a simple solution for this EASI project, we'd be interested in that. We talked about this multi-tier architecture model. There are a few models that have, many models that have used a two-tier structure. There's a few in place now that are using a three-tier structure, and one specific one that's evolving into a four-tier structure. And it's basically the same thing, just separating out some divisions of responsibility. So that's a topic for a future webinar, is this multi-tier architecture model and developing specifications. And there are a wide variety of dashboard applications. I showed some of the vendors. There are a very evolving landscape for these enterprise energy management system applications that are emerging to develop a more connected building to enterprise, building to grid, machine to machine standards or interfaces, and things like demand response applications are evolving the market and creating the need. And so this is some of the future steps and kind of where the market is going. This particular project is something that I believe is very much needed, and the question becomes, how will it evolve? Who will be the right people involved in this? And when we get some prototypes out, my vision is that there'll be a few prototypes that are up and running this year, driven by a few key end users that are willing to put forth a little effort, maybe a little funding to develop this EASI concept as a set of software API utilities that can be used in these application servers and enterprise interfaces to things like a SQL Server. So that's part of the effort underway. We'll keep you posted. If you would like more information about this, certainly respond to the email server coming from the webinar, and we can get you more information. Take a look at the website. You can sign up to be on the mailing list for this project, and we'll get you as much information as we can. So I think that is the end. I want to thank you all for attending. I did actually pretty good right at 1 hour. We'd very much like to know, and again, thank you. No need for applause, but there it is. We'd like to know, was this a worthwhile seminar? The first one we've done as a webinar in a while. So give your honest opinion. You can put that in your question box. You can just say yes, liked it, didn't like it. And we'll now take some questions, but I would like very much to know what you thought of this. Give your honest opinion about this. Was this useful information, and did it help you understand some of the concepts that we've been talking about? So please put that down in your question box there. And at this point, we'll start taking some questions. Let's see, I've got the question box open here. Bear with me a second. What happened to my question box? I just covered it. So if you have a question, you can type it now into the question box, and we'll start going through them here. I'll take them in order as soon as I can see them.
Let me help you out with them, Ron.
Okay, there we go. I had to expand my box here. So the first question was, I can't see the slides. Hopefully that was solved. I saw some things going on in the background. So the first question is from Patrick Weber. Patrick, thank you. I can't tell how many times I've seen the same type of presentation relating to industry controls as opposed to BAS at MESA conferences referred to ISO 95 standard. I'm not sure that was a question. I can't tell you either how many times you've seen it. This concept is not necessarily unique. But what is unique is that there are some people actively working on this, and not just from LonMark. We have some interaction with folks at BACnet, with SEN, with some large end users. So hopefully we are getting some traction on this. We actually have two companies that are interested and have some concepts for implementing a prototype for this app standard, this EASI standard. So there are some concepts around doing this. One of them revolves around a REST model. The other one revolves around a web services SOAP XML model. So we'll see what rises to the top. Let's see. Next question comes from Terry Doppelhauer. On some systems, maybe older, there seems to be trouble with mixed systems. Example, HVAC alarm connection, where if you work on HVAC monitoring systems, you cannot interface into or integrate systems to work together. Is this the common problem? Yes, absolutely. You kind of hit it on the head. HVAC systems don't work with alarm systems, don't work with security systems, don't work with lighting systems. The installer tends to put their own building management supervisory controller or SCADA system on top, and their data access, their database in their front end is not necessarily something that's easily accessible from some other platform, or the end user is involved in a lengthy gateway or database extraction process, often involving the original contractor or the original contractor vendor to be able to get access to that data. So if the BMS system has data in their enterprise server, to extract that data in a common way from multiple vendors becomes a gateway a science project. And it can be done, but it tends to be very costly. And so what we're talking about here is keep that building management system separate, keep it doing its job, provide a separate gateway or separate data server into the mix, maybe from a third party, that can extract that particular system's data and bring it up into this common enterprise application. Next question, has there been any consideration of extending the ISA 95 B2 MML XML data models into building automation realm rather than establishing a separate model for building systems? Yes, the answer to that is yes, that is in consideration. There are a variety of different sources of models that the EASI project team is looking at. We've had some sharing of information, as I said, from the ones that were listed. There are a wide variety of them that are coming in. Part of this is to analyze what makes sense, what's out there, not recreating, but also not overextending along the lines of what some projects have done. And I'll pick on OBIX for a second, to try and shoehorn everything under the sun into one environment has delayed the process and made it a less useful tool. So it's honing in on a specific need and then expanding over time. So yes, those are the types of things that are very interesting. And if you have some of those, please email me, send me the information on that, and we'll bring it into the mix. Next question, I think, is along the same line from Patrick. Thanks, Patrick, for both of those questions. To what extent does ISO 16484 parts 1 through 4 influence the EASI modules? The model, the same sort of thing. How does that database model work? The 16464, as I understand it, provides some good basic structure, provides some cross-correlation. It is one of those that I think was in the mix of things to evaluate by the team. The challenge with that is finding experts that can bring this in. On various calls last year, we had some experts from various industries come in and bring some of these models to the table and explain them to the team, and then we started to pick them apart to see what works and what didn't work. So yeah, that's very, very good information. Let's see, next one, just a comment, very informative from Terry, from Tom Davis. Very good seminar, aligns with our thoughts and plans to develop a staff that can deliver and implement this. So yes, thank you, Tom. And Tom, just a plug for Tom. Tom has been one of those folks in the marketplace that has delivered a multi-tier master integrator set of projects and has really learned quite a bit about this. And I think Tom has probably experienced some of the challenges around doing this sort of thing when you get multiple vendors trying to interact. Next comment was, this was very good, Robert Jones. Thank you for that. Appreciate it. Well worth the time. I appreciate that. Let's see. Martin Menzel. Hi, Martin. Glad you're on the call. Let's see. Just reading through this. I'll just read his comment. Hopefully that's everybody can see it there. Hi, Ron. Thank you very much for this great presentation. I really did understand what you've been talking about. It draws a good picture of the future, how it should be. However, I did not really get an idea about how you plan to realize it. Is there a step-by-step milestone-oriented schedule plan? Which partners need to do what in this scenario, and how can LonMark or an affiliate organization help? Best regards, Martin. So, Martin, that's a very good point. This was really an introduction, I would say, for those who are interested in knowing more about what's happening within the project to join the committee calls. We haven't really done a lot recently through ASHRAE because we've been trying to gain more people interested in this concept that can be part of this kind of task force. It really isn't specifically a LonMark committee because it branches outside of LonMark into many other organizations. So we're trying to bring various key stakeholders together. the most interesting and important thing is getting a few end users to say, yes, we agree this is a problem, and we want to create a pilot that can implement some sort of preliminary or early stage pilot project. And that's where we are today. We have a few vendor or end users that have said, yes, we're interested, so we're looking to establish the next steps here in the next couple of months. Okay, I think that is the end of the questions. Unless you've got another question, I realize that there's still 24 people on the line here, so if you had another question, type it in. If not, I'll wrap it up here, and I'll open it up to Jeremy and Sharon, Shannon, if you have any comments and closing housekeeping that you wanted to mention, now would be the time.
A number of you have asked about webinars, and so certainly we love the feedback that this is worthwhile for you, and we're happy to do some more of those. So you can find those on the website, www.lonmark.org/webinars, and we'll keep adding them on in topics that you send to us of your interest.
And I believe the next webinar is scheduled in May. And it will be discussing this open profile or common profile model, which is kind of the foundation for the EASI project to develop a common profile model for interacting with systems and subsystems into this database. And I think that one's set sometime in mid-May.
Yes, actually the date is May 21st
May 21st.
at 8 p.m. Pacific time.
Thanks, Shannon. Anything else? Okay. Thank you all very much for attending. Very much appreciate it. And again, if you have comments, I think you can send emails to me or any of the team here, and we'll respond to that separately. I wish you all a very good day, good evening. I know some folks from Europe, it's late in the evening for you. So thank you for attending, and enjoy the rest of your day.